Alright guys, so let's go ahead and go through the odd problems together here. Number 1 says write the slope-intercept form of the equation of the line through the given points. So to graph the equation of a line, the first thing we got to do is we need to find our slope. Now slope is the m value of a linear function, which can be found by doing the formula y2 minus y1 over x2 minus x1. Okay, so that's the first thing we're going to do, is we're going to find our slope using that formula. So suppose this is x1, this is y1, this is x2, and this is y2. We're going to plug it into the slope formula to find our slope. I'm going to use parentheses for the blanks that we're plugging in for. So the first term is the y2, which we see up here as 1, so that goes there. The top right is the y1 value, which is right there, that's negative 2. The bottom left is x2, which is negative 4. And the bottom right is x1, which is 2. And now we just need to simplify. 1 take away a negative 2 on top is 1 plus 2. And then on the bottom we have negative 4 minus 2, which leaves me with 3 over negative 6, which reduces to a negative half. And that's my slope. That's the rise over run. Okay. Now then step 2, we're going to take the linear function formula, and we're going to plug in 3 things. We're going to plug in y1, x1, and m. So 3 things. y1, x1, and m. So if I plug those in, I'm going to get negative 2, negative half, 2. And what we want to do on step 2 is we want to solve for b. Okay, so we plug in those 3 numbers and then we're going to solve for b. So I need to multiply these 2 things together first. So you can think of the 2 as 2 over 1. And you're just going to do top times top and bottom times bottom. Okay. Then we're going to multiply everything by 2, because I don't like having that 2 in the denominator. So I'm going to multiply by 2 here, which is going to cancel that out. We're going to multiply that by 2, and we're going to multiply that by 2. And that leaves me with negative 4 equals negative 2 plus 2b. And then we're going to solve for b. Now there was another way to go about doing that equation. Some of you guys have been wondering, Mr. Bailey, why do you do it that way by multiplying by 2? Well, because this is the way that will get you an answer every time. But there are other ways to go about solving that equation. But I just want to show you how to get rid of the denominator if you need to. But there's our b value. All right. Let's go ahead and move on to step 3. Now step 3 is the final step, and what we're going to do here is we're just going to write our equation. And when you write your equation, you're going to take your y equals mx plus b again, and you're only going to plug in 2 things. You're going to plug in your slope and your b value. So my slope was negative half, and my b value is negative 1. And there's the equation of that linear function. So that is the line that will contain these 2 points. Take a look at number 3. We're going to find another equation, but this time we're going to find a quadratic equation, and it's going to be in vertex form. Okay? So vertex form looks like this for a quadratic. Right? For the vertex, those 2 numbers are your h and k, And for the other point I give you, those are going to be your x and y values. And once again, we're going to just start by plugging in all 4 values. So we're going to plug in h, k, x, and y. And after we do that, we're going to solve for a. Right? So my y value is negative 13. A is going to stay there for now. My x value is negative 2. My h value is negative 4. My k value is 5. So we plugged in our h, k, x, and y. Now we're going to solve for a. So first of all, notice that the double negatives there inside the parentheses can be rewritten as a plus. Next, I'm going to add the numbers in the parentheses together there. Negative 2 and 4 makes 2. Next, I'm going to do the power there, and that's 4. And at that point, I'm going to move the 4 in front of the a, just so it looks like a more familiar type of equation. Next, we're going to solve that equation for a. So how do we get a by itself? The first thing I would do is subtract 5 on both sides. And then I would divide both sides by 4. Now that's a fraction. It's not going to go in there evenly, but we can reduce it to negative 9 over 2. And there's my a value. So that's step 1. Plug in your h, k, x, and y and solve for a. Step 2, you're ready to write your equation. And to do that, we're going to take this guy. Again, but this time we're going to put our a here, we're going to put our h here, and our k here, and that's it. We won't do anything with the x and y at this point. So we have y is equal to negative 9 over 2, x minus a negative 4, which is just going to be plus 4, plus k, which is 5. And there's my final equation for that quadratic function in vertex form. Number 5. We want to write another quadratic function, but this time we want to do it in standard form. And also they're giving us different information this time. They're giving us the roots. For those ones, you're going to want to use this little formula we learned a while back, where those little r's stand for roots. So you could think of this as root 1. You could think of this as root 2. And these, the random point is just going to be x and y. So for step 1, we're going to plug in r1, r2, x, and y. And then we're going to solve for a. Pretty similar to the last problem. My x value goes here, and that is 0. My r1 value is 4. Another x value, so put 0 here again. r2 is negative 1. And then the y value is 8. All right, let's work this out. 0 take away 4 is negative 4. Double negatives here becomes a positive, so you have 0 plus 1, which is 1. Negative 4 times 1 is negative 4. And then we're going to divide. And here we get a equals negative 2. All right, so step 2, we're going to plug in a, r1, and R2, but we're not plugging in the x and y this time. But we will be using the same formula. So my A value was -2. R1 was 4. R2 was -1, but minus a -1 is going to be +1. Just that. All right. Step 3, we're going to do the box method on this piece right here. So we have x minus 4 and x plus 1. We multiply to fill in our box. So we have x squared. These two are like terms. 1x take away 4x is -3x. And then we have -4. The y is still here, and the -2 is still in front. All right, and that takes us to step 4, which I'm going to have to squish over here on the left side of my board. And that's simply just to distribute. So that's a nice and easy step. We're just going to take this -2 here and multiply it into the parentheses. So that would be -2x squared plus 6x plus 8 equals y, and we're all done. So that's the standard form of a quadratic equation that has these two roots, and it goes through that point. All right, number 7, we want to solve this system using the method of substitution. So for substitution, you find where it says y equals, you circle what it equals, and you plug that into the other equation for y. So that would be -3x minus 4. And where the y was next to the 4, we're going to put what y equals, which is x minus 5. After that, you're just going to solve. Combining like terms there. And I end up getting x equals 6. To find the y value, you're just going to take this answer and plug it into one of the original equations up here. I suggest the one that has the y by itself. So we have y equals x minus 5. I'm going to replace the x with 6. And that way we can find y, which is 1. Okay? You can write your answer like that separately, or you can write it as a point, and you could put 6, 1 as an answer, because the solution to a system is the point where two graphs cross, so you could write those two numbers as a point. And that's the substitution method. Another method for solving a system of equations is the elimination method. So for the elimination method, the first thing that you want to do is you want to pick out a variable that you'd like to cancel out. So let's say I wanted to cancel out the x's. What I'm going to do is I'm going to take the number that's in front of the x's. This one has a -1, and this one has a +8. And I'm just going to reverse those. And I'm going to put an 8 on the top and a -1 on the bottom. And what we're going to do is we're going to distribute that or multiply it all the way through the equation on the top. That's going to give me the following new equation, -8x plus 8y equals, and that's going to be a pretty big number, 64 plus 80. I want to say 144. On the bottom, if I multiply everything by a -1, I get this. Now the purpose of having done that step is that it gets those variables that I wanted to cancel, it makes them exactly the same. Now I don't want them to be exactly the same, I want them to be opposites. So the next step is to pick one of your equations and multiply it by a -1 again on the bottom here. And that's going to change all the signs. And once again, there are faster ways to go about doing this, but these steps I'm showing you will get you through any problem. But if you see faster ways, go for it. Minus 7y equals -9. All right, so there's that. So all that did was changed all the signs on the bottom. Now notice that I wanted to cancel the x's. Now look at them. They're opposites. I've got a -8x on top and a positive 8x on the bottom. And what we're going to do is we're going to add these together now. So -8x plus positive 8x is 0. So they cancel out. We add the other ones together also. 8y plus a -7y is 1y. And then 144 plus a -9 is 135? That doesn't sound right. So I'm going to rethink that a little bit. Something's going on there. That's too big. And I just realized what it is that when I multiply by a -1 here, this -7 should have been a +7. So we really had 8 plus 7, which is 15. So my apologies for my boo-boo there. But that's still 135. Now if we divide it, it comes out to be smaller, which is what I would expect to happen. And I'm getting 9 for that. That's a better answer. All right, so there's your first few steps. The last thing you're going to do is, once again, just like the substitution method, you're just going to pick one of your equations. I'll go with the top one. And you're going to replace the variable that you solve for with the value that it's equal to. So I'm going to replace y with 9. And then I'm going to solve for x. So there's my x and there's my y. And once again, you can write those as a point where the x comes first, followed by the y. And that's the point where the two graphs of those functions would cross, if you want to think of it that way. The point that they have in common. All right, let's go ahead and take a look at number 11 now. It's another system of equations, but this time I have a quadratic in there, and that throws some interesting little twists into the process. So let's see how that goes. We're going to go with the substitution method. So since they both equal y, I can start by just taking each function and making them equal each other. That's step 1. Step 2 is I want to start moving everything to one side. So I'm going to move the 2x off of this side and onto this side by doing the opposite. I'm also going to get rid of the 5 on the right side by adding it on both sides. And as a result, I will now have x squared. I guess I'll leave it as red. Step 2 is in red. X squared minus 5x plus 4 equals 0, since there's nothing left on the other side now, because both of those cancel. All right, step 3 is going to be to factor. Now, we're going to use the box method for that. We'll put the first term here. We'll put the last term here. We're looking for two numbers that multiply to make x squared and two numbers that multiply together to make 4. Now, you might think 2 and 2, but I already know it's 1 and 4, so I'm not going to do 2 and 2. Filling in our box, we get this, and we know we're right if these add up to make the middle, which they almost do. 1 plus 4 is 5, but I want a negative 5. That's an easy fix. We can just make both of these negative, and now we have our answer. that. And then we're going to solve this equation. So if x minus 4 times x minus 1 equals 0, we're going to set both of those factors equal to 0, and we're going to solve each of those equations. Now, that we're not done yet. That got us the x values. We need to find the y values that go with each of those x's. But before I go any further, I would like to point out to you guys that instead of doing steps 3 and 4, you could do the quadratic formula instead. That will also work. And I think that's how we did it when we originally did this lesson. But you can also do these with factoring. So it's whatever you prefer. But I'm going to go with the factoring approach on these. All right, so the last step, step 5, is to take each one of your x values and plug them into one of the equations. I'll use the bottom one to find the y values that they go with. So for this one over here, I'm going to plug 4 in. So as you guys can see, when x equals 4, y equals 3. And for this one over here, I'm going to plug in 1 for x. And therefore, when x equals 1, y equals negative 3. And so these two functions intersect twice at 2 different points. And so you have 2 answers for that one. Okay? All right. And that does it for our review for today. Just finding equations and solving systems of equations. Hopefully that was helpful. We'll see you next time.